Greetings, everyone. This is Math 2245 coming to you from the College of DuPage. And the title of this lecture is Summer 2022 Opening Reflections. And anytime I share a video with you, please watch it as an attentive learner. A favorite analogy of mine is that we're coming from the beginning of the course on a journey to the end of the course, and it's not unlike flying through the sky from a beginning to a destination, and along the journey it may be turbulent skies. So this analogy I think is actually quite apt, and let me begin by introducing your flight crew to you. I am Patrick James Bradley. My friends call me Jim. I was born and raised in Davis County, Indiana. That's this little blue dot down here. I went to Purdue and studied math until there was no more math for me to study at Purdue. And then I got a job working in industry. I worked mostly for companies that had logos like this, beginning at Bell Laboratories, and I worked almost my entire career there in exploratory development. I left that circus to join another circus, and for a number of years now I've worked at the College of DuPage teaching mathematics. I'm a full professor here of mathematics, and my job is to teach and to learn. We also have a most able co-pilot, a young man by the name of Jesse Hayes Carver. Now Jesse's timeline is shorter than mine significantly, but he did graduate from the College of DuPage. He took math courses here, and he studied math at Illinois State and has completed his master's degree in math. In fact, here's a paper that he has published at Illinois State with somebody else, and I guess this is called Small Quasi-Kernels in Hairy Tournaments. We will talk about kernels in this class, but maybe not much else. But Jesse is the co-pilot in our analogy, but what he is more officially is the guided study group leader. And he will tell you more about when these meetings happen, but Jesse is paid to collaborate with me and to have basically study sessions that he will serve as a catalyst to enable your learning. Now it turns out that these GSGs are in fact very effective, and here you can see that the number of GSG visits, the people who go to GSG a lot, tend to get way better grades. Now that's true in general, but that's especially true because Jesse Hayes Carver is the best in the whole suite. We basically have the ace pitching for us. I was going to show you a picture of Jesse Hayes Carver, but I didn't get a replacement one in time, and so this is actually a very famous mathematician, and it's a little bit of a joke Jesse and I have. Jesse really does not look like this. So anyway, but remember Jesse Hayes Carver, a most apt member of your flight crew. And we have ground support, significant ground support in the Learning Commons. There are tutors there, but there are also people in the math assistance area. They're there over 71 hours per week to help you with homework and explain concepts. And it's a wonderful place to go. Most of these people have master's degree, just like Jesse does. And Jesse and I both actually hang out here quite a bit in between other things. And this happens in SRC, Student Resource Center, 2102. And you can see that people who go to the math assistance area tend to have success between 13 and 14% more than the people who don't. Okay, our flight plan. This is the course description. We're going to talk about geometric vectors and vector spaces, matrices and linear transformations, inner product spaces, eigenvalues and eigenvectors, the determinant function, and formal methods of mathematical proof. This mathematical proof tends to be new for some students in this class, and so we'll spend some time doing this. This is a 4 semester hour course. Now, an academic hour, as you know, is 50 minutes. And so 4 hours, 4 academic hours, 4 times that would be 200 minutes. So during a normal semester, you would be expecting to get 200 minutes of quality instruction per week. But during the summer at the College of DuPage, this is double time. We only meet for 8 weeks. And so that means you have to plan on consuming 400 minutes of quality instruction per week. And since we meet 4 times per week, Monday, Tuesday, Wednesday, and Thursday, that means it's 100 minutes per day. Now, this will be split, and you can see the time down here. But what will happen is there will be a break. I have learned that people don't want to listen to me for more than 75 minutes in a row. So you'll listen to me for about 75 minutes, and then we'll take a 10-minute break, and we'll return to finish up the remaining 25. And you see 25 and 75 adds up to 100. So we'll meet from 2 to 3:15-ish. For the 75, we'll take the break, and then we will go here. So that is the way we're going to be doing things. And this course is called a VCM, and that means we meet online as a group within times listed on the schedule. The times listed on the schedule over here, I'll tell you more about Zoom addresses and things like that as we go forward. So that'll come later. Jesse and I actually have teamed on this course before, very recently, in fact, and we actually had a wonderful semester. We had some strong students, and we really covered all these things. So we talked about methods of Gauss elimination to solve systems and find matrix inverses, evaluate determinants, and find basis for various matrix subspaces. We learned how to operate with matrix arithmetic. And we learned various ways of dealing with cofactors and use them to develop practical and theoretical tools to compute the determinant inverse. We talked about the geometry of equations of lines and planes in three-dimensional space using vectors, and we also talked about the abstract vector spaces and determining whether a given set of vectors forms a vector space under a given operation. In fact, I guess should say given set of operations. And we talked about linear independence, spanning sets, and various bases for vector spaces or subspaces. We talked about inner product spaces, which is an additional operation that's defined. We talked about finding orthogonal bases using a Gram-Schmidt process. We talked about approximately solving a system of equations using a least square solution. We had developed transition matrices when we changed from one basis to another. And we computed eigenvalues and eigenvectors and used this information to determine if a matrix is diagonalizable, and if so, find the diagonalization matrix. We used the definition to determine to have functions going between vector spaces and to determine if they're linear transformations or not. And we compute the kernel, which is also known as the null space and the range. And we obtain matrix representation for these transformations relative to various finite dimensional bases. And we also talked about a concept called similarity, invariance, and transitions or matrices. Transformations or matrices can in fact be similar to one another. This is kind of the topical outline. Again, this might not happen exactly in this order, but we actually did all of these things the last time we did this, including a couple of applications that I chose. So I'm looking forward to having a very fruitful journey with you during the summer. Jesse and I are both looking forward to that. This is the recommended, not required textbook. It's a good reference. The math department has decided this is their recommended text, and we covered significant bits of all of these chapters when Jesse and I last flew this route. I expect to do pretty much the same this summer. Now, teaching you the very best content course possible is our prime objective. You see, we want to get there on time and land safely is our objective. But we have to give you grades. So here are some thoughts about grades. My strong advice to you is to focus on learning the material, and if you do, the grades actually will care for themselves. But there will be three primary and equally weighted grading components. There will be a series of things that we will call low stakes assessment, and I will normalize these to 100 points. Then we will have two high stakes assessment. One is about midterm, and another one is comprehensive final exam. Those will both be 100 points each. So this is 100, 100, 100, or 100 and 200. This is the scale I will tend to use, and so 90 to 100 is an A, 80 to 89 is a B, 70 to 79 is a C, and so on and so forth. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself because self-care is important. And take care of each other because we're all in this together. Let's strive to make a difference. God bless you all, and Jesse and I both look forward to studying math with you pretty soon. Take care.